Good morning, chemistry class. This is Hugh coming to you Friday, April 24th, 2020. I want to talk to you about a really important topic in the next unit, which is chemical calculations. So let's just say we do something simple like find the density of a substance, and they give you the mass is 3.5 grams and the volume is 1.3 liters. And the formula for density is just mass divided by volume. So easy peasy, grade 9. You just go, okay, 3.5 divided by 1.3. And I get this number, 2 decimal 692 30769. And I put 3 dots afterwards because it really doesn't go on, it just keeps on going. My calculator will give me this number. If you have a more accurate computer, it'll give you a longer number of digits. And the units will be in grams per liter, which is a unit for density. So here's the problem. Are all those numbers part of the answer? Are part of them part of the answer? How accurate are we able to report this? And the trouble is with the measurement 3.5 grams, we know that that's an estimate because there's another digit that our balance couldn't figure out. And however we measure the volume, there's another digit and another one that we don't know. And measurements, both of these are measurements, have uncertainty. It's unavoidable. It's different than a counting unit. If you have 5 pennies, that's 5. You know it for sure. But if it's a measurement, there's always some uncertainty. For example, the number 3.500 grams is not the same measurement as 3.5. It's the same value, but this one was done on a better balance where we know that the hundreds and thousands are both zeros. This was not. This number might warrant more reporting in this number than this one does. So we have to round off, and the question is what do we round off to? It turns out the answer for this would be 2.7 gram per liter, and you probably could have figured that out. But we want to have a better way of being sure of how many digits we can report on our calculator. Reporting too many is wrong because we're saying things that aren't necessarily true. So let's figure this out. So there are some rules that we use to determine how many digits we are allowed to report in a measurement. And they're pretty straightforward, so let's go through them. Number 1, anything that's not a 0 is always significant. Any number not a 0, always significant. Zeros may or may not be significant. If there's a 0 between 2 non-zero numbers, they are always significant. It's a question of final zeros or trailing zeros may or may not be significant. For example, if I have the number 0.00044 versus 45300. Oh, let's do a 0 there. In this number here, these 3 zeros are only there to hold the place, and so significant numbers are the 2 4s for sure, and any trailing 0 is significant. So I'd say three significant digits. In this number, now zeros before the decimal, and there's an implied decimal right there, are usually significant, and we'll make a clarification of that later, but then I would say 1, those are always significant, and those 2, so 5 significant digits. Okay. So it's always based on the fact that there's always uncertainty in every measurement, and we have to be aware of that. Okay, so rule 1. Anything that's not a 0, always significant. Rule 2, any zero between two significant digits is always significant. The tricky part, rule 3. So in this example, obviously the 7 and the 3 are significant. This 0 between the two must be significant. And trailing zeros are significant. So of the digits here, and there's 1, 2, 3, 4, 5, 6 digits, I would call 1, 2, 3, 4 SDs. In this example, the 8 significant and trailing zeros are significant, so 3 significant digits. One way to make sure you know if the right number of significant digits is to put it into scientific notation. Notice the number 4.70 times 10 to the power negative 3. That's in scientific notation. It would be written out as this: 0.00470. If it was written like that, three of the digits are significant: the 4, the 7, and the 0, the trailing 0. The leading zeros only locate the decimal place, so 3 significant digits and 3 here as well. This one in significant scientific notation. Any zeros in scientific notation are always significant, so all 4, that's 4 significant digits. It does bring us to some points. For example, let's say, if I remember correctly, the distance to the Earth-Sun average distance is, I think, about 1.5 million kilometers. It's called the astronomical unit. So 1.5 million kilometers. So how many significant digits in 1.5 million kilometers? Oh wait, this is 1.5 billion kilometers. Well, whatever. So this is 1.5 billion kilometers. I'll adjust that. Let's take it back here. All right. 1.5 million kilometers, let's say. All right. So there's the 1 and the 5 for sure. And then 1, 2, 3, 4, 5. So 5 and 2 is 7. 7 significant digits. It's possible. However, unless you're sure up to the last kilometer, there's a question of whether that last 0 is significant, and in fact, whether most of these are significant, depending on the measurement. So if the measurement was done super accurately, we could report 7 significant digits. If it's not, we're not certain. So if you put it into scientific notation, this would be the number: 1.5 times 10 to the power 36 kilometers. That number has 2 significant digits, and that's the least accurate way of measuring it. If you know that your measurement was better, you'd say 1.500 times 10 to the 6th kilometer. Same number, but now you've got 4 significant figures. If you know it's precise to the last kilometer, you would have to write 1.50000 times 10 to the power 6 kilometers, and that would have 7 significant figures. Non-significant figures are always the leading zeros in any decimal number. So the ones that outlined in blue, those zeros are not significant. So 0.09060 for SD, 0.00400, 3 SD. Okay. As I said, there is a question about the trailing zeros. If there's not in scientific notation, my instructions would be write those trailing zeros are significant. So 3, 2, 5 SD. All right, I hope that helps. Please do this assignment as soon as you can. It won't take very long if you know how to do it. There's 20 questions, and you just have to write down the number of significant digits in each case. I'll show you one of them right now. This is online. So for example, the first one, How many? All you have to write down is the number of significant digits. Now you know anything that's not a zero is significant. And the question is, there's 2 zeros in that number. Are either of them significant? And the answer is yes, this one is. But no, that one is not. So the answer would be 1, 2, 3, 4, 1, 2, 3, 4, 5. 5. Okay. And that's it.